All right, we are live. Hey guys, how you doing? Chris Neidl here with our weekly, semi-weekly. Sorry for last week. We had a bit of a technical difficulty where we couldn't stream, but we are back here this week. And as soon as Ling joins, who many of you might be familiar with if you tune in regularly, we're going to talk through some of the redesign directions we're thinking of taking for the sorbent chamber, so that it fixes some of the problems around the sorbent being packed in too tightly. You'll hear all about it in a minute, but Ling has gone ahead and put together some simple sketches of that, and so we'll talk through those. She'll be on in a second. She had a little bit of a spill at home, but she said she'll be on in a sec. And so right now I'm with Jochen in Spain, and we got Seth in the DC area. And just before I hit play stream, I was delighted to hear, and Jochen, don't share any details that you don't want to, but excited that you're working away on your own little mini DAC prototype. So that's exciting. Hopefully you'll share some details with us around that when you're ready, or if you're ready.
Yeah, well, no, it needs to come together first, but so far it's all going well. I just need to find a liquid sorbent that fits the process parameters I'm looking for. And judging from the scientific papers I read, there must be something. But I'd love to have that call with Susanna to find out a bit more.
Yeah, and so we have that scheduled for, if I'm not mistaken, it might even be tomorrow. It's on my calendar.
Yeah, she's not confirmed yet, so I don't know whether it's tomorrow or not. But we'll see.
Okay, cool. I'll ping her. I'll ping her right after this call just to see if she's up, but she had suggested that time works. Yeah, so Susana Garcia Lopez is the principal investigator for a really cool project that we've been circling and talking with for a long time called USorb, which is a multi-university collaborative that is applying machine learning to sorbent discovery. And so she has an interest in the Epiphyte project, but knows a lot about sorbents as a chemical engineer. So me and Jochen and a couple of other folks are supposed to talk to her tomorrow. So hopefully that'll be an interesting call. Let me also go ahead and pop in. I see we have a few people who are watching the stream. This in the comments. I am just adding again the deck for Epiphyte, the things we're working on right now this spring and through the summer, so we can fix and rebuild hopefully a few different systems as we get into the next semester in the fall. So everything that you kind of need to know, we're trying to get that on the last page. There's a link to our GitHub repo, and we've been updating the repo to sort of reflect some of the changes we've already made. And last week we talked about how we're going to add some sort of problems and what are they called again, Seth, on GitHub? Issues, as well as milestones of so that the things that we're trying to fix and the things we need to fix will be reflected on the GitHub. So Christina might join with an update for that. So again, just waiting for Ling, who will join in a second. She's going to share some preliminary redesigns for the sorbent chamber that we want to go with to make that work better. While we're waiting, Jochen, I didn't know, or Jochen and or Seth, if you want to just summarize for the folks who are streaming in and to kind of get us up to the present of what we're primarily trying to solve for through these changes that to the sorbent chamber.
Well, from my side, obviously, Tim is not around today so far, is he? I've
Not yet.
From him. Yeah, he and I have been looking at the vacuum side of things, and that's where we suggested to lose the middle bit of the housing of the sorbent panel, and that's something that needs to be discussed with the student at UPenn, and whether they have a metal workshop and whether they can do that.
Okay. Again, we're hoping this week, but we'll hope for next week, just with Peter at UPenn getting the new member onboarded, and highest priority is to get him onto our next available call so that we can get him up to speed and find out more about him so we can move with that. I do know if UPenn itself doesn't have a shop for that, we did use a shop that is right in the neighborhood to make the original ones, so that won't be a barrier. But obviously, it'd be great if they have one on campus and it might be used for free minus materials. But let's see. All right, cool. So while we wait for Ling, Seth didn't know. Again, if nothing, we kind of shelved it for a second, but we did have a couple weeks ago some interesting chatter about the sensor and linking it to a website where the results of that sensor could be displayed. Didn't pick it up last week, but didn't know if any strokes of lightning or thoughts had emerged in your head since last we spoke.
No, I think at this point it's more about just the execution, about making sure we're getting the log files off and making sure we've got the right hosting service, and then putting the front end on that is relatively straightforward.
Okay. Well, let me know when a credit card is required for the servers or stuff like that, and we'll get going on it. Let me just ping Ling one more time here and see, because I'll show the images that at least to get the conversation going. That she came up with, and some of the descriptions that she added to our Discord. So hopefully she'll be on in a sec. And let me go ahead and share just a couple of the simple image, which I don't think has any surprises for us, of what she wrote. And I'm also going to copy some of the text that she put in, again, which she can elaborate on, but just since she is not here yet, figured we could get the conversation going. So in the comments, here's some of the thoughts that we will go over in the call. It's not ideally formatted, but let me just see if she responded to me. Oh, she said 2 minutes. She's running into technical difficulties. So, well, we can either talk about this or we can wait 2 minutes. And while we do that, talk about the NBA playoffs or something more related to carbon removal. Didn't know if there's anything on your guys' minds related to the project that we could burn 2 minutes on, or if we can.
I mean, I'm curious to get your thoughts on the carbon removal challenge.
Oh, yeah. That was awesome. Oh, yeah, it was great. So there's a member named Sophie who just joined the Discord. The carbon removal challenge was we'll start to see some of those guys. Here's Ling come in. But, yeah, it was amazing. It was really just 4 out of the 5 projects were direct air capture, really different approaches. And all of them are really quite excited about this project. So now that the semester has wrapped up, I also created a mailing list only through our newsletter for Epiphyte. And I went and counted all of the people who had indicated when they signed up to OpenAir that they were interested either in open source technology or Epiphyte specifically. So that's a nice list of about 200 people. And then I added all the people from the Carbon Removal Challenge also onto that. So I want to send that out to see if we can then build our audience. But I want to wait until we get our new UPenn fellow on board to ensure that people tune in for the first time with a really productive conversation. But yeah, it was awesome. And again, you'll meet some of those folks. Hey, Lang, how you doing? Hopefully all's well.
Good. Yeah.
Cool. So
well, the worst thing that could have happened, but
oh no! All right,
well, fast cleanup. I spilled some water over a power strip. So
I'm glad you're alive, and thank you for your forbearance for showing up in spite of that happening. So I thought I just put the image up there of the first one that you shared more as a thought-provoking image before you actually got on to explain it. I also have loaded, Ling, the other image that you shared as well. So when you want me to toggle over to that, we can also do it. But last week, just for folks who are showing up, I see we have 13 people joining the stream. We weren't able to stream because of a stupid technical difficulty that was my fault. So apologies for that. But it was actually quite a good call. And we're really zooming in on the need to try to make modifications to the sorbent chamber, which I'll show you an image of in a second, so that it can solve a couple of problems that we that we've had, in the first build. So this here, if I show you there, this is just the basic form function of it. It's the thing that slides in, and when it's loaded with sorbent, it looks like this. And there's a few different problems which I'll have these guys explain, and then Ling, based on what we discussed last week and have kind of talked about for the last couple of months, some modifications we want to do immediately to make that work better. So Ling, let me go back to this picture here, but just by way of wading into the subject, do you want to just quickly again summarize what we're trying to solve for here in terms of the changes?
Yeah, so the problem here is that we may have sorbent packed very tightly, and we're unable to get air through when we're pulling air, and that may still be a problem after we implement this. But the idea is to connect the fan to the sorbent panel directly using a tunnel, and to divide that tunnel up kind of like the top right, the 4x4 grid. That way, each portion of the tunnel will get some air. And this way, if there's a gap anywhere in the sorbent panel, there wouldn't be a path of least resistance that the air will love to go through, so that it never goes through any other parts. And in the Epiphyte channel on Discord, I listed out some possible struggles with this approach and how to amend it. I don't see this as easy, but it is a way to go. And I think so. If we have pellet format sorbent, then this would be great, I think. But if we have powder form sorbent, then that would make it pretty difficult. And putting the fan on the other side, making the air going inside may be a way to stir up and introduce some turbulence to move the sorbent around in that case. And then maybe turning the whole device 90 degrees so that the inlet is on the bottom. So it's very hard to explain that in words. But I do have a decent description of it in the Epiphyte channel. If needed, I can draw pictures of that. But
yeah,
I
had a list of things that didn't format well when I dropped them into the comments, but I can certainly we can go through what you listed there from problem it's supposed to solve, etc. But real quick, Ling, on the it is a powdery form of sorbent that we have with the new one. So when you said it might be a problem, just to look again at workarounds that could make it this overall approach work with powdery, or is it really dependent on it being more durable food than powder?
Well, it's not really. Sorry, could you repeat your question again?
Yeah, I just want to say, because we know that it is a powder, it's a pretty fine material there. So you had said that this would be problematic for that kind of sorbent form. I just want to know.
Oh, yeah, okay. I think the powder will be problematic no matter what. As an engineer, I think it's important to just work around what we have to have, and like not try to alleviate the problem by using the sorbent of the right format. I forget.
Okay.
I forget
what would be the problem? It would just suck it through the holes. Is that what's the issue with the powder?
It's gonna pull. Well, no matter what, you're gonna have problem with powder. But let's say in this case you have the fan pulling to the right, and then you have the powder being pulled toward the fan. Sorry, I feel sneezy. And then so the powder will pile up on the mesh on the side of the fan. And because it's a negative pressure, it won't, like, as in sucking toward the fan, it will never leave the mesh, and it will always be clogging up the surface of the mesh, and it's hard to stir it up. So we want to stir it up. So for that reason, I suggested reversing the fan and see if that introduces turbulence. If not, that's potentially because there's so much sorbent that the bottom is packed and there's nowhere for the sorbent to go if you blow the sorbent back into the chamber.
Okay, and just to refresh people's memory, I showed it a second ago, but you can kind of see if you zoom in on there, our old sorbent zeolite again was more of a rice grain type of shape, and the new one is more, again, more like a powder. It's much thinner than that. So we'll have pictures of that once we get back into the lab to show folks. Anybody have any thoughts on what Ling has shared so far in terms of that problem, or how she's described the larger problem we're trying to solve here, or any thoughts?
Yeah, just as by way of summary again, I think what we're trying to look at is so far the sorbent window, let's say, is rather small and very thick. And what we do not know is how the sorbent is saturated as the ambient air is blown through or sucked through. And so what Ling has come up with is one solution to try and have more sorbent surface, see more ambient air, and therefore more CO2.
This kind of gets at a little bit more, right, Ling, in terms of how you're showing the size of the box now and those arrows indicating that we want to expand that out. Is that?
That would be the last priority.
Okay.
It's actually quite a hassle. But yeah, trying to make sure that air goes through every part of the sorbent, I think it's tricky. It's tricky to test for too. Unless we take the sorbent and weigh it and don't have the problem of there being captured moisture and stuff. I think it's very hard to physically make sure that what we're doing is what we think we're doing.
Okay. With the, again, just to summarize, so with the problem with the powder that it sucks it and it gets jammed in the mesh and it's just going to kind of want to clog the holes, basically. Do we feel like when the fan, we'll have to test this, but when the fan turns off, that some of that will automatically then just fall, or if you reverse the fan, it might cause it to dislodge from the mesh? I just wonder if there could be incrementally at different stages, you could do something like that to kind of shake it off so that you get more churn with the sorbent. I don't know if that sounds like a good idea or if I missed the point entirely.
I did address this when I was talking, and it is that it depends on how tightly the powder is packed. And powder in general likes to stick with each other. And so we may have a problem still after we implement this alone. You can blow it back, but let's imagine the bottom is tightly packed. The air that blows back is not going to push the powder at the bottom anywhere because there's already stuff in the way. So there's no space to blow back into.
Okay.
So for this reason, this is why some entities, companies, they use liquid sorbent, and then they go from bottom up to introduce turbulence, right?
And we did talk about that, right? About flipping it sideways, possibly. But and I can't remember. Do we think that was a possibility to do that if we just made it vertical rather than horizontal?
I'm not sure. For powder, I'm not sure how practical it is still. But if we have the means, we should try it. It's just that Epiphyte is such a bulky piece of equipment. It's not so easy to turn it sideways.
I wonder if we did something like if you can look at the main one here, is that this is pretty heavy duty, the rack that it's on, is that if you drilled a hole that is the size of, one of the bottom, whatever you wanted to, and just placed it in there and then put some legs on it. I don't know. That's one fix that I could imagine pursuing.
Yeah. That would probably be a good thing to try, provided that we can make sure the circuits don't get messed up. In the comments, Sean says, would some sort of micro power washer work? I'm actually not sure what that is. Does anyone?
No, I don't either.
No, I'm not sure either.
Yeah, I mean, it all depends. Can we is the fan speed can you regulate that, or is it just on or off? Because if you could regulate the fan speed and thereby the airflow, then you could have some nice experiments in terms of how fast the fan needs to turn in order to keep the powder in the air when you turn it 90 degrees.
Yeah, it can be regulated.
Okay.
Seth, do you remember if it's like a knob where it's literally like a continuum, or is it 3 or 4 speeds? Or I think it's.
I believe it's continuous.
Yeah,
I don't remember. Yeah, so I think you just control it through the software.
Yeah, I get what Sean is saying now. I think he's just saying, like, imagine a hose with what's it called? Just with very, very powerful stream of water.
So to focus the airstream.
Yeah. So basically, compressed air to sweep maybe the footprint area of the sorbent panel. That's a good idea to try.
Yeah, but you only if one of the thoughts we have is to increase the size of the sorbent window, then this kind of concentrated stream obviously makes it smaller rather than larger. So we would not be benefiting from the whole sorbent surface.
Well, but presumably we don't need to run this continuously. We don't need to do the cleanup continue, right? So we can, I would speculate that we could run an absorption cycle and I guess a desorption cycle and then a cleanup cycle where we could run the compressed air through and maybe what it is we've got our 4x4 grid, and it's a pretty manual process at first, but we only leave one of those tunnels open. And so all the airflow is pushed through each one in turn, clearing it out potentially. I don't know.
Yeah. The other question is okay, so it's a powder in the bottle. Is there a way that you could possibly make Rice Krispies out of that without chemically screwing up? You know what I mean? Like is there something that could be added to it that actually makes it more into small chunks that are similar to the way that we have the pellets for the zeolite? You know what I mean?
I think not. I think you would impact on the chemical properties of the sorbent if you did that, because what we're looking for is porous surface. If you're trying to gel it together to larger pieces, then chances are that you're reducing the surface that can interact with the CO2.
Yeah.
So do you think if the fans could run forward and backwards, that if you could cause the sorbent to go back and forth in the tunnel, maybe that would stop it from packing in the back on the rear mesh? And the other option maybe is to put a buzzer or something in there to keep the sorbent like a vibration on it so it doesn't pack. Have we tried any of that?
We haven't, no.
Not trying. Yeah, it's just for ideas to work on.
Yeah. Because then
Uh,
you control the fan to maybe push pull kind of thing, so the sorbent you don't fill the channel all that much. Maybe you give it fill it 80% or 75% and then let it slosh back and forth by changing the fan forward and backwards.
yeah, I
If
think for that idea, maybe if you fill the chamber less, then the micro washer / compressed air idea is even more relevant. If you don't fill it all up, the top is just gonna be empty, right?
yeah.
There's no way you can not fill it all up, but still cover the entire footprint of that 4x4 grid.
Malcolm had a
But
question.
the acoustic, what's it called? The acoustic, like mechanical stimulator thing is an interesting idea. A lot of things I think we just have to try, and we should pick one direction and then try it.
Yeah. Malcolm, to that effect, I just posted it on the screen there, the question that he asked. Thanks, Malcolm. Malcolm, do you have any actual, given the size of what we're working on here, anything that's sort of off the shelf that if we wanted to look at some kind of device that did ultrasound waves for a device of this size that would be a good fit? If any ideas, please post some links in the chat.
I guess that also makes me think. I was in Florida and saw a hurricane simulator thing, and they created a vortex in a chamber.
Huh.
Could we get the sorbent to be spinning in a vortex? If you get the right speed and the air spinning in the right way, maybe you can keep the particles suspended in a vortex.
Yeah, I think this is an age-old question that Edward was trying to solve for a very long time, right? If he could have, he probably would have.
Oh yeah.
They always clump together. They love clumping together.
Yeah.
Yeah.
Tested.
Go ahead, Yoka.
No, I said it just needs to be tested. I mean, if the fan is, you can control the airstream, then if we were prepared to at some point turn the thing by 90 degrees and you put a glass cylinder or something instead of the sorbent window, then that could be tried out, and you just need to find the right fan speed that keeps the powder in a kind of equilibrium, sort of. That would at least ensure that you have the most surface available.
Yeah, I want to talk to the one of the carbon removal challenge teams that presented last from Waterloo. They're the ones that I showed a brief image of, where they had like a vertical kind of fluidized approach, and their sorbent wasn't entirely like pellets either. It was actually, when you saw it in action, it did look kind of snow globy. So if I can get them onto I wonder if anybody here who's watching right now actually is from that team. If anybody is from the carbon removal challenge that had the fluidized bed sorbent approach, make yourselves known in the chat. We might pull you on to speak to it a little bit, but it's in the video to that. You can kind of see them doing it, but we can ask them how they made it work and see if they can join us for some thoughts. Ling, was there anything else in the notes that you had put down on the Discord that you wanted to speak through, or did we cover it all? Otherwise, I was going to ask Yoken just about what he's worked out with Tim about more the frame, right? Eliminating the gaps in the slide-in. You had some progress on that, if I'm not mistaken.
Yeah, I don't have much more. I think it's good to document ideas. There's not really like a way to find the best way forward. Like there's no way to know which one will work unless we test it. So
Yeah,
we should
which
just
is
write
why-
down all ideas.
Can we add those as actual issues to the GitHub link?
Yeah, I haven't touched the GitHub. Sorry, I've been swamped lately. I'll have to see. I noted it in the channel, but it's there.
Yeah.
I'll have to see if I have bandwidth to touch the GitHub anytime soon. I've been really swamped actually.
No worries. Thanks. Yeah, I'm just trying to get onto it from Costa Rica. I had another problem with it where it kicked me off and sent a message to my cell phone that I don't have here. So Matt and Christina are trying to get me on so I can go ahead and add those, but I have some limitations in terms of how I describe it for a more technical audience, but I can give it a go. Let me see here. Oh, I'm not sure what that is, Yoken. Is that a
It's a ultrasound like transducer thingy. It's a device that induces mechanical movement via sound.
Well, I think we should try and test it as is with the powder first, and then I think it might give us some answers or some indications as to which direction we should think this.
Yeah, I usually need observations to come up with ideas.
We got to get our new guy in the lab, and that's what we're working on. As we said last week, is to try to get that person.
Let's see how much of a problem this is.
Yeah, exactly.
Yep, exactly. What we're aiming for is to, sorry, my camera's off, is to get, is to be able to have a stream each week from the lab. That's the ask, so that we, rather than saying, I wonder if this would work, we can get to a position where we do it live on screen here, but we need to have our new member joining. Everything else is pretty speculative, obviously, until then. Okay, well, any other ideas or thoughts related to this, or any other piece of the work for the time being from any of y'all?
No, just what I said before, and I think that triggered Link's thoughts and suggestions. That I think at this stage we do not know how the sorbent saturates, and we don't know if we blow in ambient air on the one side, and we're trying to extract the CO2 on the other side through a vacuum. We don't know how much of that captured CO2 we're actually seeing on the other side, and the thicker the sorbent layer actually is, I think the stronger that effect will be.
Okay.
What about a magnetic, like in a beaker, you could put a magnetic stirrer? What if we put a magnetic like a stirring device inside the sorbent chamber?
That's actually pretty smart. Yeah, so you can have magnets outside and the magnet inside that moves the sorbent around. Yeah,
it's like a magnetic dough hook. If you've ever made bread or pizza dough, right? You'd have it sort of move around so it keeps shifting the material. Well, let's keep that in your head, Jay, if you have that as an idea. But maybe we'll start with the simplest approaches first and just see how the fan performs. Sounds like that's the best.
We have to learn how the powder behaves, because just because it's a powder form doesn't mean we know anything about it. We have to observe how it clumps or how it flies around.
Yep. Okay.
I mean, honestly, could we just flip the sorbent chamber every couple runs?
Good idea. Yeah, that's probably the easiest way.
You can't just to control the fan to do forward and backwards. Wouldn't that be the same?
We don't know, right? So it's basically gravity versus fan is kind of what we're thinking of. If we, it's almost like a rotisserie, if you had something that allowed, you could take it out can do it. That obviously isn't a long-term solution, but it's something to test with. All right. Well, let's do this. Sorry, go ahead.
The one thought on this magnetic stirrer. I thought about that as well, but I only know this from a chemistry laboratory, and then you normally have it on a heating plate or something. So normally the stirring works with this being on a surface that has this magnetic induction. I'm not sure whether you can make it. You can do it from the outside also. And if we have a solid plate on one side of the sorbent panel, I'm not sure that would work so well.
Yeah, that's the tricky part. We need an actuator, and the actuator has to be somewhere. It's not invisible.
What's an actuator? Sorry, that's my dumb question. My job.
An actuator in engineering terms is just something that makes something else happen. So like literally anything like a fan or a stick that someone manually pokes, they're all actuators. So in this case, if you have a magnet living inside the sorbent chamber, you need a magnet outside, something with a magnetic force outside to move that inside magnet around. Like there's no way to move it around without some kind of outside force, right? It's just gonna sit there. So an actuator in this case would be like some kind of magnetic jig outside that either you program it to move around in a certain way, or you manually hold it up with your hand and it'll move the inside magnet around to stir the sorbent.
Okay.
So I agree. It feels like what we need to do is, get in the lab, observe what happens, try some things manually, and then once we figure out what works manually, we can figure out how to automate it.
Mm-hmm.
Yep, agreed.
Okay. Well, what I think we'll do is until we get our person in the lab on with us, we might hold off on streaming just for our audience's benefit, and then resume the stream when we have a live human with expertise at UPenn, which hopefully I was hoping it would be this week, but we've confirmed that person is in. We just have to get them in. So we'll probably, if that isn't next week, we'll probably do this as a Zoom, and then we can resume the streams once he's in place and providing his ideas and body and brain.
And maybe even give him another Zoom call before going live again, so that he's primed and warned about what's going to happen.
Yeah. Oh no, that's exactly right. We want to get to a point where he's good to go, and then this could be more of an experimentation call.
Yep.
All right, cool. So Jochen, you and I will be on the call with Susana Garcia Lopez from USorb. There might be some interesting things to report back. Not of immediate concern, but she's a sorbent expert, and we'll talk to her this week. And then hopefully we'll have a few other people show up on the stage side of the call from the Carbon Removal Challenge who are interested. I'll send out emails for that. But if we're not on next week as a stream, it's because we don't have position yet at UPenn. But hopefully that will be next week. If not, then we'll hope for the second one, or for the following week. All right. Well, that was about 45 minutes. If anybody has anything else they want to share, otherwise we can hop off and resume next week.
No, good.
Wait.
Go ahead, Ling. What was that?
Jochen started talking at the same time too. Did you want me to talk about the sorbent chamber shrinking, or someone wanted to talk about something else, right? It was something about the sorbent chamber.
Oh yeah, about
to explain the other image. It's unrelated.
Yeah. Yep. Let me grab it. There you go.
Yeah. I'll just briefly talk about this. So the idea is that our sorbent chamber is currently very thick, 1.5 inches, and imagine that if it's packed full of powder, the 1.5 inches is like the thickness. The length is equal to maybe 3 of your fingers, or maybe 2 of your fingers if you have large fingers, just like the width of it. So for me, it's 3 fingers. It's very thick, and we want to have a way to reduce that thickness of sorbents, because if it's very powdery and tightly packed, then we can't get air through. And then with one set of heating wires, it's also going to be pretty tough to heat all of it for, I think, adsorption. So, or absorption, I think absorption. So the idea here is to have an insert, and it really needs to tightly hug the aluminum frame, which will be the hard part, I think. And it's once you make it, it'll be impractical to adjust the 80/20 frame, and then the inside, the insert frame. Um, you if there's a way to make the screen for this inside frame so that it's adjustable, moving anywhere along the. I don't think it's that easy. I think it's easier to just have 2 wooden frames, and then sandwich a screen in the middle, glue it together, and then put it inside. That's the easiest way to create this, but it wouldn't be adjustable. But it's minimal materials. So using this idea, you could create an insert that shrinks the thickness of the sorbent to whatever you like, maybe half an inch or so. So like in on the right schematic at near middle of the page, the yellow hatch pattern, that's the sorbent. So we want to squeeze the sorbent from the full height of the 80/20 to maybe half or less, and see how that goes. So it may be tough because every time you want to test a new thickness, you gotta create one more of these. But this allows you to test different thicknesses of the sorbent without making the entire thing over again.
Could you have it so that screenling could have, you take it off, and then whatever depth you want, you could then put it back on there, and it fastens to the side of the frame. So if you wanted to do an inch thick, you could do that. It's just because it would be a standard dimensions for that screen, right? It'd be this whatever we decide to set the dimensions of the square at.
I'm not sure. So there's always a trade-off. If you want it to be adjustable, then there's a lot of engineering. If you want it to be made very quickly and easily, then it's not adjustable. So we got to choose.
Yeah.
The 2 horizontal profiles are the issue. Those need to be made longer or cut depending on which direction you would do. The vertical ones are fine. They can keep that length. That's the only thing you have to bear in mind.
So the purple arrows, I didn't want to go through that here. I think it's very complicated because if you do decide to expand the footprint of the sorbent chamber, then you have to also change the window, the aluminum sheet with the 4x4 grid windows. And then you also have to redo the heating wires. We'll have to see re-drill a lot of the holes. Thanks, Chris. Yeah, so at some point your 80/20 brackets might start clashing with each other. Yeah, there's a whole so where there are these clevis pins, you can see that on the other side of the 80/20, just outside of that, I don't know if it's possible to have a pointer here, but where the clevis pins are, so the clevis pins are the 7 bolt-like looking things in the middle, or in the sorbent chamber. They're on the two sides of the mouse food, and each one is touching basically right next to an 80-20 piece, a small 80-20 piece. On the other side of the 80-20 piece, there's this bracket, and so there's a hole in the aluminum sheet at the bottom for which this was made. So we would have to redo that hole. We'll have to patch up that hole. There's just a lot of considerations.
Is that whole is that bottom and top hole actually really necessary? I mean, it's screwed on to the, I guess, sides. It seems like it's got maybe over.
It's potentially not necessary. It's potentially not necessary. I don't know. So we can try it without redoing the whole hole. We have to patch up the old hole. I think it's just for stability, that one. But we will have to redo the sheet itself.
Yeah.
Because what's the point of expanding the sorbent chamber if the window is still the same size?
Yeah, right. So we're looking at a new sheet anyway. So we just would drill the holes in a different place. On the vertical ones, what you were just saying, Jochen, see how there's about probably 3 inches between the bolt on the outside of the 80-20. We can see 5 of them on screen right now. Those could be shifted over as well, right? That bolt could be basically touching the other one on the far end of the frame. So it looks like we get about 3 inches, right, pushed over, and then we could get more up. But we're going to need a new screen in any event.
I think as I was saying a few calls ago, I think in order to maximize the effect of carbon captured, you want to have as much sorbent surface visible or seeing the ambient air that you're blowing in as possible. So the larger the surface of that, i.e. the window, the better that will be. But I think we go back to what Seth and I were saying before. We'll do this with 1.5 inches of this new sorbent first, then we can do it with 1/2 inch. We see what the difference is, and then we can take it from there.
Okay.
And at some point you're probably sorry, so incoherent. You will probably see diminishing returns as you enlarge the window, right? Because of the shape of the duct that we're using. It doesn't mean that if you increase this sorbent window to like the entire outside dimension, it will work the best.
No, that's true. But at the same time, I think there is a point of sorbent window size that has the maximum effect of CO2 capture.
Yeah. No, I'm not disagreeing that it should be increased.
No, but you're right. I mean, the way this goes, otherwise you would, a bit like your initial sketch, you would have fans, need to have fans all over the place. And then the whole thing would not be cone-shaped on either side, but basically circular. And then you would have airflow over the whole surface of that window. But that I think would be a bit of an overkill.
Okay. Well, let's pick it up next week and talk or share in the meantime on the Discord. And again, I will keep you guys posted day by day if we have a time in which we can engage with our new member at UPenn. But yeah, we'll take it from there.
Okay.
All right. One point, Chris, if the call with Susanna is not tomorrow evening, I would appreciate that. If it is, then I'll make myself available. But tomorrow evening is the time when I'm at that hackerspace from 6:30 onwards now, because we hadn't heard from her. But see how it goes, just so you have that in the back of your mind.
I'll send an email with all of you guys copied, and she's back from vacation. That was the thing that caused the delay. So we'll just pick a time that works for everybody, but you'll see that email go out from my inbox in the next 7 minutes.
Perfect.
All right. Bye, guys.
Thank you.